Hi, I'm Eric Kai, the chemical statistician, and today I'm going to illustrate the first of two methods of calculating expected counts in contingency tables. This first method relies on proportions. In a later video, I will illustrate a second method of calculating expected counts based on joint probabilities. Expected counts are essential for performing tests of independence between two categorical random variables. Let's consider an example. Here I have the hypothetical survey results of people's ice cream preferences. I have two categorical random variables, gender and ice cream flavor. Gender has two categories, men and women, and ice cream flavor has three categories, chocolate, vanilla, and strawberry. And my null hypothesis is that gender and flavor are independent. In other words, it doesn't matter what your gender is, your likelihood of preferring any one of those three ice cream flavors is the same. My alternative hypothesis is that gender and flavor are dependent. In other words, men and women have different proportions of preferring the different ice cream flavors. Now, those are rather verbose ways of describing my null hypothesis and my alternative hypothesis. So let's illustrate what that means by actually calculating the expected counts. So the first method of calculating expected counts relies on the fact that the proportions of people who prefer chocolate, vanilla, and strawberry are the same for either gender. That's the definition of independence between two categorical variables as applied to this example. So if the proportions of the preferences are the same for either gender, we can calculate those proportions, or we can estimate those proportions by first finding out the counts for the individual flavors and then dividing them by the grand total. And the counts for the individual flavors are just these marginal totals that I have up here. So they're 450, 320, and 150. So to calculate the proportion of people who prefer chocolate, I just have to go $450 divided by 920. Okay? And I've calculated that ahead of time. This is equal to 0.489. Okay? And the proportion of people who prefer vanilla is just 320 divided by 920. And I've calculated that to be 0.348. The proportion of people who prefer strawberry is just 150 divided by 920. And I've calculated that to be 0.163. So according to my null hypothesis, the proportion of people who prefer these three flavors is the same whether or not you're male or female. Now, applying that null hypothesis, we can figure out the expected counts by multiplying these proportions to the totals of the individual genders. So the expected count for men who prefer chocolate was just 0.489 times 280. And that, I calculated ahead of time, is 136.92. The expected count of men who prefer vanilla is 0.348 times 280, and that is 97.44. The expected count of men who prefer strawberry is 0.163 times 280, and I've calculated that ahead of time as 45.64. And if you do the same calculations for women, just multiply these proportions by 640, and you will get 312.96, 222.72, 104.32. As a sanity check, these three numbers should add up to 1. These three numbers should add up to 280. These three numbers should add up to 640. And these 6 numbers should add up to 920. And I encourage you to do these checks on your own. And they may be slightly off just because of round-off error. I've rounded these proportions to 3 decimal places, and I've rounded these expected counts to 2 decimal places. So there may be some round-off error when you sum these values up. But these 3 should sum to approximately 1, and these 6 should sum to approximately 920. So this is the first way of calculating expected counts in contingency tables. In another video, I will illustrate how to get these same expected counts by joint probabilities. So, as always, you can visit my blog, The Chemical Statistician, to get your short lessons and in-depth tutorials about statistics, chemistry, and machine learning. And you can also follow me on Twitter at ChemStatEric. Thank you for watching this video. Stay tuned for my follow-up video about calculating expected counts based on joint probabilities. And I hope that you learned something useful today.